Hi, I'm Sriram. Today I'll be presenting my final project, Recognition of Facial Expressions from Grayscale Images using Convolutional Neural Networks. Firstly, what are the uses of facial emotion recognition? With significant developments to human-computer interactions, VR gaming and driver monitoring systems now require facial emotion recognition. A high emotion recognition accuracy has been achieved in controlled and consistent environments. But challenges still persist in naturalistic conditions due to changes in facial pose and subtle differences between expressions. So my problem statement is to develop a convolutional neural network based model to automatically recognize facial expressions from grayscale images. Kaggle website hosts a facial expression dataset which is available for public use. It contains about 35,000 examples of faces with expressions such as happiness, neutral, sadness, anger, surprise, disgust, and fear. Ian Goodfellow, inventor of GANs, reported a human accuracy of 65 to 70% on this dataset. Coming to the technology, I implemented a pre-processing step to normalize pixel values which are originally from 0 to 255 to 0 to 1. And I developed 4 CNN based models. Model number 1, pre-trained VGG16 model with fine-tuning. Model number 2 is a VGG style model. Model number 3 is a 5-layer convolutional layer model. Model 4 is model 3 but with class weights. As you can see, samples for class disgust are much lower compared to class happy. A detailed view of the different models. Model 1 has about 3 million trainable parameters. Model 2 has about 6 million trainable parameters. And model 3 and 4, since they have the same architecture, they have about 4.5 million trainable parameters. So all models were optimized using the same settings, which is a stochastic gradient descent with momentum and decay, and a reduction of learning rate upon reaching a plateau. And I saved the models at the epoch where the validation loss was the least. And now coming to the results, as you can see, model 4 has the best test accuracy of 65%. The confusion matrix here shows performance for individual classes. This model has the highest accuracy for happy and surprised classes and least for fear classes. And here are some examples of the areas where the model assigns higher weights for different emotions. The colored regions are the areas of interest for the model. It is interesting to study the model patterns for all these different emotions. I wanted to show some challenges. Here are a set of images where the model failed. I added the label and prediction for all these images. Have a look and see if you agree with my model. And thank you for this opportunity. Thank you to Professor Zoran and the TS for offering this course.